only. So equivalent resistance calculation, simple, based on the formulas, right? That is 1 by R equivalent. So reciprocal is written. So reciprocal code I am using here, starting and ending letter, RP, reciprocal, and REQP, equivalent resistance in parallel combination, or equivalent in parallel combination. So reciprocal. So 1 by R1 plus 1 by R2 plus 1 by R3. Right? In series combination, I used the code R equivalent S. S stands for sum and series. So sum of the resistors R1 plus R2 plus R3. To avoid the confusion, I am keeping logic like this. Right? To avoid the confusion, which is reciprocal, which is sum. Right? So series, sum, direct. Now, my question to you is here, a new problem I am giving you with the circuit only. Here, so this is the circuit given you. What the combination of the resistors I am giving you is R1, R2, R3, and R4. Identify the combination of resistors here. Simple task is given you, identifying the combination of resistors. Are they in the same combination, all the 4 resistors? Are they in the same combination given you here? No. Then how to identify the combination? So I will give you one more simple logic here to identify combination. Right? Simple logic. So find out first this one, junction. What is junction here? That which is simply it is a point. Junction means it is a point which was connected by minimum 3 or more than. So more than 2 wires are connected. That is equal to 3 or more than. Right? So more than 2 wires or minimum 3 wires are connected. Then it is said to be a junction. So now identifying the junctions here. So this is one of the junction. This is also a junction. Here is one junction. Here is the other junction. Right? So here, taking that junction size A, B, C, D. So here between A and B, are there any resistors? Yes, R1 and R2 resistors are there. R1 and R2 resistors are there. So here, whatever it may be, the number of resistors are connected between 2 junctions that are said to be in a parallel combination. They are called as here branches. So R1 in different branch, R2 is in different branch, right? So R1, R2, R1, R2. Here they are in the different branches. So how many connections are there between the junctions that are here said to be in a parallel combination? They are called as here branches. So 2 branches are there, that 2 branches are in parallel combination. If you assume one more branch here, that also in parallel combination, right? I something R5 suppose. Here R1, R2, R3, they are in parallel combination. That will act like a single resistor by the combination. So that is only here equivalent resistance in this circuit, like between A and B. That is in parallel combination that you need to find out. Then R3 and R4 also in parallel combination. So that equivalent resistance we will get. So it is in the first one P1, second one P2, second loop, first loop, right? So here that equivalent resistances, right? That equivalent resistances are in series combination, right? Equivalent resistors are in series combination. right? R equivalent in loop 1 and R equivalent in loop 2 are said to be in series combination. Got clear idea about what I discussed here? Have you got clear idea? If you observe junctions, that number of components are connected between the junctions, right? Right? They are called as here different branches. If they has different paths, right? Minimum 2 paths are needed. More than 2 paths also allowed. Whatever it may be, if you have different paths, that all they are said to be in parallel combination. That paths are called as branches. If the components are connected within the same branch, they are said to be in series combination. In different branches, they are said to be in parallel combination. Right? So now I will give you one more idea. Right? So about the branches and here now look at the figure I drawn on the screen, or sometimes in your question paper they may give you only this one, then remaining part, the rest of the diagram will not given in your question paper. So how to understand this one? So how do you find out a combination between these? You see, find out junctions first. 1, 2, 3. So this is here junction. Then connected again here. I made single wire, single part. So again, this is known as junction. Then here it is dividing again into 2 parts, single into 2 parts. So here it is also a junction. Then combining again, here is a junction. So A, B, C, D, right? A, B, C, D. What they are here? Junctions, right? So between A and B, you have 2 branches. You have 2 branches. Between B and C, only single is there and no component is there. No component is given, right? So no use, right? If there is any component in this single path, that's said to be in series combination, right? Nothing is there. Then between C and D, yes, you have 2 paths. There are 2 branches, right? So branches, do they have 2 resistors or more than one electric component connected in the same branch? Answer me. Pick out. In any branch, did you see more than one component? Yes, I am able to find out more than one. R2 and R3. Here also there is one more, R4 and R5. So here they are connected in the same branch or in a single path, right? Between any 2 fixed points, right? In a single path, they are said to be in series combination, right? So first of all, you need to find out equivalent resistance in this. Then here also you need to find out equivalent resistance. This equivalent resistance Req in the first loop will be in series combination, parallel combination with R1. Then R equivalent in second loop Req2 in parallel combination with R6. Then they will give you equivalent resistance again, right? So that the first equivalent resistance and second equivalent resistance, right? So first equivalent resistance REQ1 is in series combination with the parallel combination with the R1. So reciprocals you are taking and finding equivalent resistance by those called as R equivalent in a loop 1. So I am taking as L1 suppose for easy identification. That 1 by R equivalent in a L1, and you will get one more here by the 1 by REQ2 and 1 by R6, right? Or in parallel combination. So that will give you 1 by R equivalent in a loop 2. So overall loop equivalent resistance you are finding as REQ2 by writing reciprocal REQ L2, right? So that REQ L1 and REQ L2 are in which combination? Series combination. Single part. They are connected again in single part. So then you will find out REQ1 L1 plus REQ L2. That is overall equivalent resistance in the whole circuit. So these are the steps you are following in solving these type of circuit diagrams. Are you clear or in confusion? Use your opinion as reaction here. Quick reaction. So you are clear how to solve these type of circuits. If not clear, it is not a problem for you. I'll give you example. Just it is general explanation without the values. Now I go for the values for these resistors. Right, same combination I am following here for the previous example what I am given you. So this is your circuit diagram. Then I'm taking the values as 2 ohms, 4 ohms, 6 ohms, right? 2 ohms, 4 ohms, 6 ohms. Then here I am giving you 1 ohms, 2 ohms, 3 ohms. Now tell me how these 4 and 6 ohms are connected in the circuit, in series combination or in parallel combination. These two are connected in the same branch between the junctions, right? So they are said to be in a series combination. So here you will get equivalent resistance, right? Equivalent resistance is 10 ohms, right? Here is 5 ohms. Then here 2 and 10 are in parallel combination. So 1 by 2 plus 1 by 10. That will give you 2 into 10 and 2 plus 10. So 12 by 20. Then here you are writing the reciprocal for the equivalent resistance in the loop 1, right? So loop 1 is equal to 20 by 12. So first loop solved. So finally I got equivalent resistance in the loop 1 is equal to 20 by 12. Then in the second loop, so here 2 and 3 are in series combination. I got the equivalent resistance as 5 ohms. Now 1 and 5 ohms are in parallel combination. So that equivalent resistance in the loop 2 is reciprocal. So 1 by, that is 1 by 5 plus 1 by 1. That what it will give you 5 cross product of numerators now to the denominator. So 1 into 1 plus 1 into 5 will give you 6. Then R equivalent in a loop 2 parallel combination will be given as 5 by 6. Now this 5 by 6 ohms and 20 by 12 ohms, right? 5 by 6 ohms and 20 by 12 ohms are in a series combination. Then how do you find out that? 5 by 6 plus 20 by 12. So what is LCM here? 12 is the LCM. So here 2 by 2 multiplication is needed. So 6 to the 12, okay, denominator solved. 5 to the 10 plus 20. Then what I got here, the value is, here, simply I got the value is equal to 20 plus 10, 30 by 12. It is what? Reciprocal, right? Then what to do? Writing the reciprocal here for the value what I got. So what I will get? 20 by 30. So cancelling 4, so 3 4 ja, 3 10 ja. So 4 by 10, that is will give you 4 ohms. 0.4 ohms. Clear? Clear? Is it clear? How I solved? Medicine.
Sir, why did you took the reciprocal?
Where?
30 by 12.
30 by 12. Where I am written here? Okay, okay. So here 1 by R equivalent. So here, sorry. Correct only answer. Here, reciprocals, right? Oh, I made a mistake. Sorry. I did a mistake. Thank you. Here actually, that equivalent resistance of these loops REQ in loop 1 and REQ in loop 2 are in series combination. Just you need to take directly here sum. So what is the sum? Here it is in loop 1 is given as 20 by 12. Loop 1 is given as 20 by 12. So 20 by 12 plus R equivalent in loop 2, 5 by 6. Then here the LCM is 12. So here I need 2 by 2 here multiplication to make it denominator as 12. So equivalent fraction is written for 5 by 6. That is 10 by 12. So here 20 plus 10 in the numerator. That is equal to 30 by 12. So cancellation 6 5 ja, 6 2 ja. That will give you 2.5 ohms. This is the correct answer. Thank you, Medashree. Now it is clear about everyone. Now it is clear. Yes. Okay. So this is about circuit diagrams and finding the equivalent resistance. So simple logic, find out the branches first by identifying the junctions. So whatever it may be, the number of paths you are finding between branches, between junctions, they are called as branches, right? As many as branches are there, they are all together in parallel combination. If you find the electric components within the same branch, they are said to be in a series combination. Is this logic is okay to find out a series and parallel combination in the circuits? This logic will help you. Branches and junctions. This logic is good. Okay, one only said good. Okay, whatever it may be, find out your own logic, right? If it is not helping you, find out your own logic, right? So that what I said, series combination, single part, parallel combination, multiple parts. Again, you require junctions, right? So this is about today's class. So numericals on resistors completed. Then only two topics are left: Kirchhoff laws and electric power, right? Kirchhoff laws and electric power. So we may require 2 more classes to complete this one, right? So tomorrow we'll discuss about Kirchhoff's laws, right? It may complete tomorrow. Then law last day we will discuss in this electricity about electric power and overload. So thank you for joining in the live class. Right, be in the same time tomorrow morning at 6 a.m. Thank you.